All right, we are going to take our time with this. Part of it is you do have memorization to do, so I want to give you time for your memorization. The other part of it is chapter 5 is difficult. I don't know. I enjoy chapter 5. I think chapter 5 is one of the best ones because it is reasoning. It makes you think, which is why a lot of times you guys don't like it, but it's not just regurgitation. It requires memorization, but you don't just have to regurgitate what you memorize. You actually have to think about your problems. It's more like puzzles that you have to solve. So I don't know. I really enjoy it, but we are going to take our time with it with units 1 or section 1. I believe I have it split up with over at least 3 days, if not 4 days. So, which maybe I'm totally lying to you. Actually, I think I am. I think I only have it split up over 2 days. That's entirely different than 4 days. But
I think my dad's gonna bring me.
okay, so we're going to start with the identities that are in section 1. Now, the nice thing is, the ones in section 1, you should already know most of them. So, we're going to start. I'm going to name these. You do not have to memorize the names. I'm never going to ask you, state all the reciprocal identities. It's never going to come to that. I'm never going to ask you to actually state any of the identities. All of these, you're going to remember them for usage, and that's for it. I'm not going to ask you to state anything. So that's not the point of the memorizing. I don't like to have you guys memorize something to regurgitate it. And the whole thing with the unit circle, that was a one-time thing. I really didn't even like doing that, but that was just to kind of get you going at the beginning of the semester with the whole fact that you actually had to memorize stuff. Reciprocal identities. Let's see. Again, you already know all these, or at least I hope you know these. This is the fact that sine and cosecant are reciprocals. So I know this is something that some of you still struggle with a little bit, but it's not a brand new concept. It's not a brand new idea. So then the second one would be that cosecant and secant are reciprocals. What did I say? Okay, yeah, sorry. Cosine and secant. And then lastly, tangent and cotangent. Okay, so those are the reciprocal identities. Again, you just need to know them to be able to use them. I'm not going to ask you to just regurgitate them and spit them back out. Second set are quotient, which again you have had. That's the fact that tangent is equal to sine over cosine. And that cotangent is cosine over sine. Okay, so those are the old ones. Okay, so the new ones. And I wanted to say it's a new one, except for there's 3 of them to it. This is the Pythagorean identity. All right, how close are you to being caught up? I know I wrote them kind of fast. I know, I don't want to go too fast. I wrote those down quickly just because they were review. I want to take time on this last one. Am I okay to go down here like this? No? Okay. There?
Yes. Okay, you're good with that.
Okay. I don't want to go yet. I want to make sure that you hear what I'm saying. Huh? I don't want you to catch up. Okay. All right. If you really want me to go. All right. So, Pythagorean. Now, we kind of used this when we were getting our unit circle. When we were getting our unit circle, remember we set up a right triangle, and we discussed how one side of the right triangle. So when we were doing our unit circle, we created right triangles inside that unit circle. We had our angle there. And with our unit circle, this side was 1. And we discussed how this side, our x value, ended up becoming cosine, correct? And our y value ended up becoming sine. So the Pythagorean identity comes from that Pythagorean theorem on that right triangle. So that's where our Pythagorean identity comes from. Now, there's 2 more Pythagorean identities, but they come from this one. So I want to show you how to get them, so hopefully you don't have to memorize them all. You can memorize one of them and then get them. You can get them from this one.
So why is the square before the x rather than...
Okay. Yeah, let's talk about that. Okay, with trig functions, whenever I square a trig function, if I had sine x and I wanted to square it, I would do that, correct? Well, we want to shorthand that. We don't want to write the parentheses every time. And if I just drop the parentheses, it would look like this. Well, that would become confusing because that looks like the x is squared, correct? So we don't want to do that. So to get shorthand, what we're doing is we want to say we're squaring the entire function. So what we do is we move the square right next to the function. So that means the function is squared. So these 2 things are equivalent right here. So that's just shorthand so we don't have to write the parentheses every single time. Nothing. Absolutely nothing. Except for it's an extra thing that whenever we're doing a lot of squared problems, it's going to clutter them up. And trust me, we are going to have problems with a lot of squares in them. So it's just shorthand. It's kind of like, with the square root, instead of writing that 2 every single time, we drop the 2 off. It's just because math teachers or math people are lazy. Okay, so here's your first Pythagorean identity. So to get the second one, what we're going to do is we're going to take that and I'm going to divide both sides by, let's say, sine squared. Now, just to make sure you're okay with the algebra of this, whenever I divide this entire side by sine squared, that means I can divide each thing by sine squared, right? Because it's just like distributing. Okay, so what's sine squared divided by sine squared? 1. Okay, what's cosine squared x divided by sine squared x? What's cosine over sine? Cotangent. So, cosine squared divided by sine squared is cotangent squared. Think of it like this. So, remember, this means this, right? Since they're both squared, what I can do is I can pull that squared out like this. So then what is 1 divided by sine squared x? Cosecant squared x. So here's your second Pythagorean identity. So you get the second one by taking this one, dividing everything by sine. How do you think you're going to get the third one? Dividing everything by cosine. So if I take all of these things and I divide every single one of them by cosine squared x, this, what? Cosecant? 1 over sine is cosecant. Yep. Okay, so sine over cosine is tangent. Cosine over cosine is 1. And 1 over cosine squared is secant. So that's your third Pythagorean identity. Okay, your book has 2 more sections of identities. They have cofunction identities and even and odd identities. We have already talked about those. I am not expecting you to memorize those and use those in the proofs that we're going to be doing. So you can ignore those. You do not have to memorize those. So these are the ones that I want you guys to memorize. So I lied to you a little bit whenever I told you have to memorize that whole bottom of the book. I'm going to be throwing some of them out as we go. Just most of the entire bottom of the book. Okay. Now, next thing we're going to be doing is, for most of this, for Unit 1, we're going to be simplifying. We're not going to actually be, we're going to be calling it verifying instead of calling it proving, even though it's going to actually be proofs, but we're going to be simplifying. So I want to lay down some rules for simplifying, just so you kind of know when to stop, because with simplifying, it gets a little, I don't know, you get started and it's like, okay, when do I stop? Especially with trig, because with a lot of these, you can switch it, and then you can switch it back, and you can switch it again, and it's like, okay, so what's it supposed to be? Is it supposed to be sine or cosecant? Am I supposed to use Pythagorean and turn it into cosine? And when do I stop? Okay. First of all, these rules are if possible. So, we do the best we can. It's not always possible to make all these rules apply. So, the first rule, what we try to do the most, is we try to get a single trig function. Said it's not always possible. We try to do it if we can. We also try to get no fractions. So if you're working through a problem, you end up with 1 over sine, you don't leave it as 1 over sine. You change it into cosecant, because that gets rid of the fraction. If we can get rid of the addition or subtraction, we try to. Again, not always possible, but through the use of Pythagorean, sometimes we can. Getting close to all the rules, but I'm trying to think if there's anything else. I think that's about it. As we go, we're going to add more things to this. But I think for today, that's all we need. All right. So let's go through some examples. Okay, we're going to start off with super easy. Now, the point of these is not to, give you an example that is always going to work. Every single time you see a problem, you're going to do this, because it's not going to work. These are puzzles. What I'm trying to give you is tools that you can try. You try it, it doesn't work, you're going to have lots of times where you're going to have to go back and start over the problem. You always need to start the problem, though. A lot of times, starting the problem and failing it shows you how to actually solve the problem. Because once you fail it, you kind of see, oh, that didn't work, but I get it now. I know how to solve this problem. The biggest thing that I see as a problem is people will sit there and just stare at the problem, trying to figure it out in their heads, and will not write anything down. You have to try. Don't fall into that, because I know a lot of you can sit there and with a lot of regular problems, you can sit there and look at them and you can have it all figured out in your head before you even start writing it down. Not all of these you will be able to do that with. You have to start writing. Just trust me on that, okay? I've been doing this for a while. Trust. There are problems that whenever I look at them, I may not be able to figure them out. I start writing. Okay, so let's start on these. And 80 ideas how to solve the first one. Yeah. Yep. A lot of times, and again, this doesn't work on all of them. A lot of times, one of your best tools is to change everything into sines and cosines. Because everything will change into sines and cosines. So one of the places, if you're stuck on something or if you need a starting point, is to change everything into sines and cosines. So then on this one, the sines will cancel out. So there we go. We simplified it to cosine. So that is always a great starting place, is to change whatever you have into sines and cosines. Okay, second one. Where do you want to start? There's actually two really good ways to solve this one. Hey, we can go over both of them if you want me to. Not the good way. It would work. It would be longer. Longer.
Well, and then do like.
It would work. It would be longer. Okay. One way is if you see multiplication, multiply. Don't resist the urge to multiply. If you see multiplication, multiply. Now, some of you had wanted to change cosecant squared into 1 over sine squared. Now would be the time to do that. Because if I did that, I get cosine squared over sine squared, which is what? Cotangent squared. Okay, great. Now what? Yeah.
Well, you actually could then say at the end by increasing cosecant to 1 over sine squared x and then cosine squared x over sine squared x. And then it would have the matching equation. But you could have also at the very beginning changed 1 minus cosine squared x to sine. So that would basically just be nice.
That's the second method. Wait, what? What? Okay, I don't care what.
So when you multiply cosine squared, like the fraction 1 over sine over x squared, you multiply cosine 2x. So the bottom becomes sine 2x, cosine 2x, like all one big thing. So like why do you
Yeah, this here became this cosine squared x over sine squared x, which becomes that.
But,
Uh-huh.
so when you multiply cosine squared of x with cosine squared of x, what does that equal?
Wait, it didn't equal anything. It just was this. But then I changed cosecant squared into 1 over sine squared. And then that gives me cosine over sine, which is cotangent. Now this isn't the answer yet.
So we just multiply the
Cosecant times cosine doesn't equal anything. I have to change the cosecant into 1 over sine.
okay, but why is it my power?
Okay, now what is cosecant squared minus cotangent squared? Go back to this. What is cosecant squared minus cotangent squared? 1. It's your Pythagorean identity. It just needs to be rearranged a little bit. Nothing says your Pythagorean identity has to stay in this form. You can still rearrange it using addition and subtraction. So cosecant squared minus cotangent squared is equal to 1. Yeah, don't memorize it exactly. You have to. It has to be in a usable form. Yes. Okay, so, and this is what Chloe was getting to just a little bit ago. Yeah, I can also take this here and right here, what is 1 minus cosine squared? One minus cosine squared is equal to what? Sine squared. So I could also take this up here and say that I have cosecant squared x times sine squared x. Now, since those two things are reciprocals of each other, what do they equal? What? Right here. Subtract cotangent squared from both sides. So you get 1 equals cosecant squared minus cotangent squared. It's not going to always look exactly like this. We can subtract things from both sides. And that's how I got this up here. 1 minus cosine squared is equal to sine squared also from this, because I can subtract the cosine squared from both sides. So these equations, you can't memorize them exactly how they are and plan on using them exactly how they look. They have to be workable. You have to be able to manipulate them as well. They're not going to be perfectly like that every single time. This is why we're spending a lot of time on this. Okay, how about this one? Where do you want to start? Okay. So, if cosecant, if I flip that over, that would put my sine on top, correct? And secant, if I flip that over, that would put cosine on the bottom, correct? So then what's sine over cosine?
And then you gotta do some more stuff.
Nope. Why? Tangent. Okay, now example 4 is difficult.
This is gonna be just, let's plug it in there.
Oh.
My plan is to present you the first section or unit 1, and then Friday I'm gonna give you work time because I figure you're gonna have a lot of questions.
Yeah. I'm just like mind blown by
This is fun.
Wait, so why
Oh my god, I love this stuff.
why is it sine over cosine?
Okay, cosecant, the reciprocal of that would be 1 over sine, except for if we divide by a fraction that flips it over, correct?
Oh,
this. You have a chart of the different like,
so
things.
they
do other
flip
things,
over
and
and
then, like,
then
Yes.
they flip
you
over.
do, like, subtract
So,
and stuff, and
so it would be like
then you
this.
plug that in, and then you do some more work, and then when you get another thing, you plug that in, and then it's just explaining is terrible. If you can just visualize what I see.
I don't know how I want to visualize what you see. Okay.
There, is that a better explanation?
Yeah.
That better? There, if you
I
don't
guess that's true.
if you don't get it, just tell me. There's alternate ways of explaining.
Oh,
The word problem.
are we having word problems?
Because it was
No.
the same thing.
We're done with word problems.
And we're doing
And we're done with graphing. That's why we split this up. Can you imagine trying to do this with word problems and graphing along the way?
I think a lot of us would just commit.
That's why I split it up. Okay, this one now. Okay, this one is difficult. This is one of those places where I'm trying to give you a tool to help you out. Okay, you have to look for relationships. One of the relationships is the fact that secant and tangent are related. Secant and tangent are related through the Pythagorean. Pythagorean is a very powerful tool whenever it comes to this stuff. You always want to look for a relationship through the Pythagorean a lot of the times. Okay, so if I can make Pythagorean work for this, then I can get this simplified. The problem is the tangent is not squared. To make the Pythagorean work, we have to have squared things. Okay, the other problem is I need a plus sign, but I have a minus sign. Okay, so currently this looks like it's going to be a mess. Okay, so I think I may have written this one down wrong. Oh well, we're going to try to do our best.
Wait, you did or you didn't?
I have no idea. I made it up. Hey, it says simplify. Okay, what you want to do a lot of times is you want to use difference of squares. I'm sure I wrote this one down wrong. I am absolutely sure because I want a minus sign up there, and Pythagorean for this uses a plus sign. So I am 100% sure I made up this one up wrong. No, it's not going to fix it because I want to use difference of squares. Difference of squares is the tool that I want to show you about using.
Wait, so you wrote it down wrong.
Yes, from my mind. My mind. So this is a tool I was trying to show you how to use. Is difference of squares will create that square for you.